Hello everyone, this is the video lecture for College Algebra, Math 1414, Section 2.1. We're going to be talking about functions. First off, we need a definition for functions. I'm going to say that it's a set of points such that each x value has only one y value. Okay, a set of points such that each x value has only one y value. I'm going to demonstrate this with our first problem. So I'm just going to write this up. And instead of simply just saying, well, this is your answer, I am kind of talking you through it as well. So this is the first problem. And they say, is this a function? And you're going to say yes or no. So it's a pretty straightforward question. I also want to do one that is, I don't know, that'll work. And so I'm going to parallel this one here. I know that sounds kind of weird because you already know the answer now. I'm going to parallel this one here with the next problem as well. Now, these problems have some extra stuff going on with them, a part B and a part C and all that kind of stuff, but I'm just wanting to talk about this function thing right now, okay? So let's just look at these two guys. Is that a function? Yes or no? Okay. So my definition is that each x value has only one y value. This is an x, this is a y. Same all the way down. This is an x, this is a y. And so I'm looking at each x value and I'm saying, do I have only one y value with it? And right now that looks fine. I mean, 5 has a 4. Okay. Does this have only one y value next to it? Yep, that looks good so far. But now I'm kind of getting a little nervous. So let's keep going. Does 9 have only one number next to it? Yep. Does this number 9 have only one number next to it? Well, yeah, it does. But hold on. I have these duplicates. I think what they're trying to do is this is the unsimplified version. I'm using finger quotes here because it's not a simplifying thing. I'm making a point that this is written too long, and I think I need to condense it down. What they're trying to say with these two right here is that we have 5, 4, and 6. And right here with these two guys, they're saying we got 9, 4, and 6. You see, this 5, hey, has a 4. The same 5 also has a 6. That sounds a little weird. It's not two 5s. There's only the one 5. X equals 5, number line. Right here, x equals 5. There's only one 5. There's like a 6 and a 4, but there's only one 5. Even if it's written twice here, there's only one x equals 5. So does this x value have only one y value? I would say no. That alone says it's not a function, but let's keep going. Does this one x value have a single one y value? No, it does not. So is this a function? No way. Let's compare and contrast with this one. I have a 0 here. Does it have only one number next to it? Yes. I have a -6. Does that one only have a single number next to it? Yes. 6, have a single number next to it? Yes. And this -9? Yes. So everything's yes. Do we have any duplicate x values? We do not. All of the x values are unique. And so I don't have to worry about trying to rewrite it like we did last time. I'm going to say yes, everything's fine here. So though I gave you an official definition, and I will be using it again and again, I want to give you a not as official definition here. You're going to look for repeated x values. You're looking for repeated x values, and if you find any repeated x values, then watch out because it probably is not a function. I would just have to go and check. Okay, cool. They ask for the domain and range for each one of these. The domain are simply the x values. And I'm just going to list them out. I mean, that's all it really is here. So we have a 0, we have a -6, we have a 6, and we have -9. That's it. The range are the y values. And so I'm going to list out all my y values for this one. -5, -9, 6. We already have a -9, so you don't have to write it twice. I know that you're thinking, well, we have a repeating y value. That's not what I was asking. I was saying look for the repeating x values. Okay? So there we go. I know it's kind of a little weird, but you do 2 questions, you move on, you won't see it again. So 2.1.11, I mean, you might see it a little bit here and there. X plus y is equal to 26, and they say, is this a function? Now, I want to repeat our definition for this here. It says we only have one y value. Okay, a lot of x's, but only the one y value for it. So I'm looking for a single y value. I'm basically saying y equals blah, 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 blah. A single y. And if I can get this, my goal here is to get this. If I can get this, then I would say yes, it is a function. Okay. If I can't get a single y by itself for some reason, then I would say no. So let's kind of just simplify this thing. My goal is to get y equals something or other. How would I start solving for y? Well, I'm going to minus an x on both sides. And so then I got y is equal to 26 minus x. Did I get a y by itself? Did I have a single y for any x? Yeah, so we're good there. I would say yes. Okay. Turn the page to 115. I've got x squared plus y squared is equal to 1. Is that a function? Now this one's a little different. I want to get y by itself. I want to get y equals whatever. So I'm going to minus x squared on both sides. And I get y squared is equal to 1 minus x squared. Well, how do we get y by itself? Well, I guess you could square root both sides. The thing is when you do that, you get a plus and minus. Remember, there's a thing there. You need to have a plus and minus whenever you square root both sides. And so what you're actually saying here to me is that y is equal to a positive square root of 1 minus x squared, and y is equal to a negative square root of 1 minus x squared. Looking at this holistically, do I have only one y going on here? The answer is no. I have 2 different y's. This is not a function. So I would say no. I guess the quicker way, again, there's always a quicker way to do these things. You're just going to look at the power. You're going to look at the power of your y. And if it's an even power, it's not a function. If it's an odd power, you would say yes, it is a function. And the reason why I say odd powers is because right here, isn't that a 1 power right there? Similarly, just let's say we had a cube. And so I would minus x on both sides. How do we get rid of the cube? We cube root. But the cube root does not have a rule to put a plus and a minus here in the front. It's basically just a positive or whatever. There's no rule for that. So looking at this, do we have only one y value? Yes. And so that actually works for all the odd powers of y. Yes. And the even powers of y? No. So there's your rule for that. New stuff. 2.1.29. So now they're establishing that we actually have functions, and they do this with f of x. F of x. I know we say it so quickly, so long. So f of x. So this is a function, and this is what we'll be dealing with mostly in Chapter 2. And they're wanting part A, in particular, f of -8. Notice that we got x, and now it's -8. So what is x equal to? -8. And so what I'm going to do here is say -8 squared plus 3 times -8 plus the 8. I guess what you can say is that we're plugging it in. Plug it in. That's kind of a common term that we use for this. Substitute is another one. So 8 squared, we got 64. I got a -24 plus the 8 here. I should get a 48 out of this. And that's it. Pretty simple. Part B is actually going to be a little bit more difficult. What they're wanting is f of x plus 2. So what they're wanting is that we have this original function, and now I'm going to want to plug in wherever there was an x. I'm now going to plug in this x plus 2, an expression. And so I'm going to just recopy this part right here. I'm just recopying it. Ready? Here we go. X squared plus 3 times x plus 8. Notice that I'm leaving it blank. I'm just saying whatever I had an x, I'm going to leave it blank just for a little bit because I'm sure that I'm going to put something inside of the parentheses. What is inside of the parentheses? Do you see? It's an x plus 2 in this particular case. The idea here is that you're copying the original. Instead of using x, you're just going to leave it blank. And then you fill in the blanks with whatever they want you to use. It's similar to this. We did the same thing. We just used numbers here. Now it's just a lot of letters. This is not so easy or fun to work with. Notice that we have a square right here, which means there's 2 of these. And then this guy, I'm going to have to distribute my 3. So you can't distribute the square, nothing like that. But you can FOIL it. So x times x is x squared. X times a 2 is 2x. 2 times x is 2x. And then 2 times 2 is 4. These things can just kind of hang out and wait for a minute. Combine like terms, you can see that the x squared is all by itself, but we got these x's here, and then we got our numbers. Putting it all together, x squared plus 7x, and then plus 18. That is the final answer. Whew. And that was just part B. Part C, that's actually easier. It says f of negative x. Well, what I want to do here, again, I'm going to rewrite my original here, going back to the original. Instead of writing x, I'm going to leave a gap, a space, a blank. So blank squared plus 3 times blank, was it plus 8? Yeah, okay, cool. And so what goes inside the parentheses this time? You can see it right here. Negative x, negative x, negative x. And so notice that we have, and here you can distribute the square because these are multiplied. Notice that we have 2 negatives, make a positive, and then x is still squared, so x squared. Here I got a negative 3x, and then a plus 8. And there you go. So that was a lot easier than the other problems. That's good. And then something new. So then they start showing you graphs, and they say, hey, are these graphs functions or not? So they're wanting to use this thing called vertical line test. Vertical line test. It's very similar to what we just saw about functions. I want only one y value. Only one y value for each x value. We do that with the vertical lines. So here's an example. I'm gonna do that here in a second. In fact, let me show you what this will be. This is the graph of that one. It's kind of like a rectangle. But I'm just going to do an example over here if that's okay first. So let's say I have this nice flowy cubic. You don't have to know that's a cubic. I'm just telling you. I'm going to run a lot of vertical lines, and I want to see, do I only get one y value each time? So a vertical line. Did I only touch it once? Yep. Touch it once? Yes. Touch it once? Yes. Touch it once? Yes. Touch it once? Yes. 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 Yes, 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 yes. You can see I'm trying anything I can, anywhere I can, to try to find an issue, but I can't find one. So is this a function? The answer is yes. Because everything's fine. I didn't have any kind of issues. I only had one y value. I only touched it once with each vertical line. Over here, I run one vertical line, and you can see immediately that I have 2 y values. 2 y values. I don't know why I wrote it like that. 2 y values for that single x value. So is this a function? No. So vertical line test, you're running vertical lines, and you're seeing, does it touch only once, or does it touch twice? And if it ever touches twice or more, that would be no good. Let's do a similar problem here. 2163. This time, I have kind of like these things that go on the side over there. And I'm supposed to run some vertical lines. Once. Oh, nothing there. Nothing. I don't really think I care about anything if there's nothing. Once. I'm never touching the graph twice. That was the thing. 2 or more times, no good. Every time I touched once, or not at all, so I don't really care about those. So I didn't ever find an issue. Is this a function? And you would say, yes. You're trying to find out where there's a problem. Notice all my lines. Does this happen here? Look right here. Do I have all those lines right here? No. I did one line. I found there was an issue. No good. That was it. I don't even have to try anything else. Okay. And something new. You'll see in Chapter 2, especially these first couple sections, that it's always going to be, hey, here's something new. Here's something new. They give me a graph here that looks something kind of like this. Of course, I'm not making it perfect by any means. Over here, we got a 4, and this is going down to, I don't know, -3, let's say. Over here, we got a 6, and then I got right here, let's say that's going to be a -2. Okay. They say, well, g of x is equal to -3, so then x is equal to what? Looking at this graph here. What they're wanting to do is kind of go backwards. Notice that this right here, this is a y value, and they want to know what the x value is. So the y value is right here. Oh, I'm hitting it right here. I'm touching it. So then what's the x value? Where was it located? At 4. We could do something very similar here. This is another kind of problem. Whoa, hold on. I did it wrong there. G of -2 is equal to what? Notice that this guy is an x value now. That's an x value right there. So x value, -2. I go up or down. Up. I'm hitting it. So what's the y value there? 6. Okay, so just different formats. Not hard at all. Okay. And something new. So now they're wanting the domain and the range from a graph. These are actually very important questions, so definitely pay attention to these guys, okay? I have this graph. I'm going to use a different color here so you can see it. I have an open circle, and then it kind of comes down like this, and then it's a solid like this right here. This is not going to be to scale by any means. I'm going to try my hardest, though. Let me label these. So this right here is at -3. It's crossing right here at -2. And this is right here, a y value of -1. And this up here is supposed to be a y value of 8. Okay, so now you can kind of see where I'm going there a little bit. Okay, notice that we have a circle versus a solid. So they're wanting to find the domain and the range. So the domain, what's the domain of this? Well, domain is x values, possible x values that are actually used in the graph. So is there anything going on over here? No. Is there anything going on over here? No. But there's something going on over here. Where would I start? Where did I start my domain? I'm going to say I'm going to start at x equals -3. It's right there. This is where I'm going to start. And then I'm going to end at x equals 0. That's right. 0, because this is 0 right here. 1, 2, 3, 4, 5. Where's the x value where we're actually stopping? Do not put -1. That is a y value. This is 0 right here. That's an x value. So I'm going from -3 all the way to 0. That's what I want to say. But how do I put this English into math? That's the point here. So to do this using interval notation, you would do the -3, 0. But we need to use parentheses and square braces accordingly, depending if you can actually touch that endpoints or not. Notice that right here we have an open circle here, an open circle. So we're going to actually have to use a parentheses there because we're not actually touching -3. That's what the open circle is indicating. It's saying don't actually use -3, just get really close to it, like -2.999999, but not -3. Here, though, we got a solid. That's what the graph gave me, a solid right there. Solid requires a square brace. Solid says that we're actually touching. 0 is a legitimate number that we should be using on our graph. So solid versus what I would say a circle. Again, here you're going to use parentheses. Anything that's solid, you're going to use square braces. So that's that. The range is the y values. Use a different color for that. Y values are going up and down. Notice that we got -1 right here all the way to 8. And also notice that I'm starting from negative going to positive. We're used to reading downwards. So you would say, oh, it's going from 8 to 1. No, 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 no. It's going from -1 up to 8. From negative to positive. Isn't that how we do number lines? From negative, then we're going to positive. So same thing on the y-axis as well. So I want to say I'm going from -1 and I'm going all the way to 8. But I need to fill in parentheses and square braces accordingly. Well, notice that my -1, there's a solid right there for that. It's associated with a solid, so I'm going to use a square brace. But the 8 is associated with a circle, so he's going to have a parentheses. Okay? There's your domain and range of that graph. They're going to ask a couple more questions about this stuff. They say, what are the x-intercepts? The x-intercepts. I should probably just write that out longwise. Intercepts. And so that's whenever the graph is touching the x-axis here. You can see right here, it's touching at that -2. So what you put in here is simply a -2. That's it. It's very simple. What is the y-intercept? Notice that it's a singular term. When is it crossing this right here, this vertical line? Right there. And the y value for that is -1. Okay? So it's like, where on the number lines are you actually, touching or crossing or something? Lastly, they're going to say, hey, what's f of 0? And you have to, whoa, sorry, I kind of gave it away. F of -2, and you could probably guess it's 0. So I'm saying, hey, this is my x value, and I want to just find out what the y value is. Just so happens to be right here at 0. Okay. So that's the full question. Let's do another one, 2183. So a very similar question here. I'm starting here at -2, and I have I'm trying to make this look pretty good here for you. I have a solid, and then it goes whoosh. Trying to get the whoosh. That's a pretty good whoosh. Okay. Cool. Some other things, just in case. So that's a -2. Right here at -5, it appears that it would have an x value of 9. They're going to ask about that here in a minute, but it's not really concerning our domain and range yet. Okay, just start fresh, right? Okay, so domain and range. Domain, possible x values. Notice there's nothing going on over here, and all of a sudden right here, where does it start? Starts right here. You're saying -2. X values are this stuff here. This is 0. 1, 2, 3, 4, 5, etc. You get the idea. 0 is actually where I'm starting. So I'm going to say I'm starting at 0. At x equals 0 to make it look cool. And then is there a graph going right here? Is there a graph at this x-axis or x value? Is there a graph right here? Yes, yes, yes. There's a graph actually everywhere as you keep going. See that arrow? The arrow says it's going to keep going. And so how do we say forever and ever in math land? I'm going to say to infinity. So I'm starting at 0 and I want to go to infinity. So let's write it out. 0 to infinity. And infinities always use a parentheses. Always, always, always. 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 Okay. So, but what's going on here at 0? Notice that I had a solid associated with it. Solid, square brace. Okay. So this guy, he'll always get a parentheses, mainly because it's a concept. Infinity is not really a number, so you can't really touch it. You don't really, you can't really sit at infinity. It's just a concept, so you can get really close to it. Range. Range are the y values. So, again, our first inclination is to go down or something, or to say, oh, well, -2 to whatever, infinity. So this does keep going down. It just doesn't go down very much. You could see that from the graph. It does keep going down. It's wanting to go down, 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 down. Eventually, it'll take a long time to get there, but eventually it's a negative infinity. negative because it's going down. So all the way down here. So it's kind of interesting. I want to say -2 to negative infinity, but that is incorrect. Remember that we're going from negative to positive, or rather, most negative to most positive. So what I'm getting at is that we're here at negative infinity, and I'm going to go up, up, up until the -2. I'm going to go from negative infinity all the way to -2. At -2, is it a solid or is it a parentheses? Or is it a solid square brace? There you go, because there's a solid right there. And that's your answer. This is one of the most missed questions that I've seen on quizzes and exams and all kind of stuff. Main reason why? People flip them. They'll say -2 to infinity or all kind of different variations of this. I understand. We're used to reading down, but we're trying to go from the most negative to the most positive. And although we didn't quite reach the positive land, we did get pretty close. It's more than negative infinity. So that's good. Okay. So they say, what are the x-intercepts? Again, plural. When is it crossing this line? You would say none, never. What is the y-intercept? So where is it crossing this line? You would say, right there at -2. And then finally, they say, find f of 9. That's what these other things were for. See, this is my x value at 9. I go down, I go over. The height is at -5. And there you go. One last question. 21101. Okay. So they have, this is a word problem, by the way. F of x is equal to -2.8x plus 286. And then I got a g of x is equal to 0.01x squared minus 5.1x plus 375. And they're wanting to know what would these formulas yield if you plugged in an 80. That's part of the word problem here. I can't remember exactly what the 80 comes from, but it means something. You plug in the 80, and you get some numbers. And you can see that it's pretty easy to plug in some numbers into these guys, right? This guy right here in particular, I got 62, and it's supposed to be a percentage. Plugging in the 80 into the other formula. Oops, that's a minus. I would definitely use calculator for this thing, and I got 31% here. I think that you're rounding, maybe. I can't really remember. I'm just showing you what I got. It'll tell you if you need to round or round whatever. They'll say, of course, in my math lab. So this is part A, essentially. Then they have this graph on the side, something similar to this. That's like a bad graph there. And here at 80, the graph yields a 65%. So they're wanting to know which of these two results here are closer to the 65. And of course, 62 is much closer. And so I would say f of x is better. Notice I'm saying f of x is better because that was an f that I used. So there you go. That's your answer to part B, I think. And that's all I got. So if you have any questions, of course, let me know. Thank you very much. Have a great day.